You are watching TFI.
Greetings! If you just happen to be passing, these type of videos tend to be found by people in the YouTube search results and they just watch it and then they just move on. That's fine. But if you want to see any videos that I do in the future, and I've got a 5-year back catalogue of Inventor videos, mate, then get subscribed and check out all the old videos that I've done, and indeed subscribe to see all the new ones. Anyway, let's get cracking. Let's hop on over to Autodesk Inventor 2019. And just before we get started, I need to go over some settings that might be different between your Inventor and my Inventor. Go to File, then Options, or Tools, Application Options. You can copy the settings from this tab. Copy the settings from the Sketch tab. I've got my hardware profile set to quality. I've explained that in a different video, what the difference is between quality and performance. Again, I don't want to go off on a tangent on that. That's the display tab. Color tab, I've disabled enhanced highlighting. And most importantly, on the file tab, configure default template. I've got mine set to measurement units millimeters. If you're working in inches, that's fine. You can just convert what I type into inches, but I'm using millimeters because I'm in the United Kingdom of Brexitville. And then we'll close this down and we'll get started. Right, everything that I'm doing is in Inventor 2019. I can't guarantee that what I'm doing will be available in earlier versions. It should be dating back a couple of versions, fine. But anything older than that, I don't know what to tell you, mate. Yeah, I've got to work with the latest version. I can't not use something because someone might be using a 10-year-old torrented version of Inventor. Do you know what I mean? So there's nothing I can do about that. But we're going to start with an IPT. And just one last thing, Soz. I know this is annoying and irritating, but I'm going to be covering a lot of advanced features later on. You can follow me as I go, but if I was to explain every single thing that I'm doing and why I'm doing it, this video would be 3 times as long, and that would put off a lot of new starters from watching it if it's that long. So I'm just going to do it. I'm just going to get it done, model it up, and you can follow me as I go. But there'll come a point where a lot of the things that I'm doing are very approximate, dragging surfaces around and drawing splines which aren't exact. Just try your best to do things as close as I'm doing it. So let's start, mate. Let's start. Enough of the waffling. Right, 2D sketch on the XY plane. Then we're going to do a center point circle from the center yellow dot. Pull away, and we're going to type in dia equals 26 millimeters. Press return. Escape. Finish sketch. And then that's the start of our turbo impeller base profile. It is a very small object. You can increase or scale the numbers that I'm putting in by 10 if you want. It's just the suggestion for this video came from a guy on the TFI Discord server who's modeling up an impeller for a 3D printer, so it is a very small object. Extrude up by 1 mm. Okay, press return. And then we're going to do another 2D sketch on the XZ plane this time. F7 to slice the graphics. Project cut edges, which is on this drop down here. Window select right to left to pick up these 3 edges down there, and then convert those into a construction line, which is useful for a little bit later on. Regular old line command, snap to the mid green dot here, move up on the vertical, so it snaps to the vertical, and then type in 10 and press return. Move to the left on the horizontal, snap to the horizontal, 3, return, and then escape. And that should give us something that looks a little like this. And then we're going to jump into a 3-point arc, snap to this endpoint here, and this is approximate. Click around about here, pull away, click. Make sure it doesn't create any constraints or any glyphs appear as you're doing it. Click that green dot, and then roughly there. Right click and OK. Go up to the perpendicular constraint. Click there to there. There to the construction line. Right click and OK. We're then going to create a horizontal constraint between the joint between the 2 arcs, this one here, and the midpoint there. And then we're going to tangent between these 2 arcs. Right click and OK, and everything should be blue and fully constrained. It should say fully constrained down here, and it looks absolutely delicious actually. Right, finish that sketch. Revolve. That profile should be automatically picked up, and then the axis is going to be that line there, right? That one there. Then OK on that, and then look at that, mate. Isn't this 3D CAD stuff easy, man? It's easy. 2D sketch on the bottom for that face. Project geometry, that edge there, and then right click and OK. And then we're going to jump into an interpolation spline. Yeah, I know, this is where things start to get very approximate, and we're going to select the edge of this circle, so it snaps to the circle. Click approximately there, approximately there, and then approximately there. Then click the tick. Right, that gives us a spline. This spline is the center line of the blade. So it's it doesn't need to be exact, but roughly, like say for example, dimension between that point and then that point there. Right click, aligned. We'll make this roughly 6.5. Right click and OK. And this is no good. You can see the spline starting to bend out from the circle and then here. But we don't want that. So we're going to grab this endpoint here and just put it down to about there. And then we're going to right click on the dot, activate the handle, and we're just going to twist the handle so it's about there. Yeah, that'll do. That's fine. This point here, I want to just grab that and move that about there. I think we're good, mate. I think that's fine for the center of the blade. So that was all very approximate, just dragging stuff around. That's what I mean by it's going to be difficult for you to follow, and every time you do this, it's going to be different, unless you do start putting dimensions between the points. And yeah, I'm not going to do that. Right, finish the sketch, and I'm going to extrude that. We need to convert this into a surface extrusion. We're going to select that sketch line, and then we're going to grab the arrowhead and pull it up, and we're going to change this distance to be 10. Yeah, that should be fine. It should fall short by about, well, by exactly a millimeter from the top, and then OK on that. And this is where things start to get quite advanced. We're going to go to create freeform, convert that into a freeform surface 4x4. Let's keep it at that. We don't want to make it too complicated, then OK. The more surfaces, if you were to go 8x8 or 6x6, you'll get more squares, which means you've got more control over the profile of the fan blade. But I'm trying to keep this as simple as possible, so you can. And the more squares you've got, the more different mine will become to yours over time. And I want to try and avoid that happening. But we're going to delete a couple of faces here. We're going to delete. Hold down Control on the keyboard. Delete that, that, and that, and that, and that. I think that should be enough. And then OK. And then delete this point here. OK. That looks alright actually. Quite happy with that. So this is the kind of the top of the fan blade. That's fine. And then I think I want to delete that edge there. OK. Right. Let's see how this turns out. It's I can probably tell I'm kind of I've practiced, but I'm kind of making this up as I go. I don't want to delete. So I don't know how this is going to turn out. It's sort of different every time you do it. So edit the form. I'm going to click this point here, change the space to local, and we're going to pull this out by roughly 4 millimeters. Doesn't have to be exact, just roughly 4 millimeters. Yeah, I think that should be fine. We're going to accept that. What I'm not a fan of is this line here bending like that. This is very difficult to change. So what we're going to have to do once that's done is subdivide this back into... Do we need to do that? Do we need to do that? I don't think it matters actually, because this curve here is inside the solid base. See that line there? Changing color. That's inside of the solid. Anything this side is going to be inside of the solid, so I don't think it matters. But what we could possibly do is grab that point there and then use local space and then twist. Yeah, we could possibly do that. Just rotate it around so it's slightly less kinked. Yeah, that's almost. Oh no, it's not, is it? No, it's not. Let's grab this, put it about there. It's just, that's that. You know what it is? That's fine. That's fine. Let's see if this works. Right. Okay. On that, most of the bend is actually inside of the solid, so it doesn't really matter. And then we can finish the freeform. Right. We can right click on the extrusion and turn that off because we don't need him anymore. And we can now convert this into a solid. So we're going to go to thicken, quilt, new solid, pick our freeform, change it to be 0.5 both ways, and then OK. And you should get something like this. Right, yours might not work. If it gives you an error, you'll have to go back into the form and make sure there's no bizarre, strange joints in any of these. It should be, I mean, this is far from straight, but It's fine, it's workable. But you can grab sort of the edges and then change it to local space again, just sort of pull them around, and you know, it's how you want this blade to be. I can't tell you what you want it to be like. I'm gonna just grab that point there. I'm gonna move it slightly in further to roughly there. Yeah, that's good. That's good. Okay, on that, finish the freeform. Yeah, that's a little bit better. Right. Okay, I'm happy with that. Okay, the next thing I'm going to do is, you see this termination here is not good, so I'm going to go to Direct Edit, pick this face, and then pull it just by, I don't know, 2 mil. Pull that out, and apply that. And then, what am I going to do next? What are you going to do next, Neil? I'm going to combine, expand solid bodies. I'm going to combine these two into one solid. Then we're going to do a ruled surface. This is the advanced stuff that I'm talking about, like ruled surface, combine, thicken, quilt, all that kind of stuff. It's stuff which I should really be explaining to you why we're doing it and what's happening, but I'm just doing it, and you can follow along and sort of make your own mind up on what's happening. Click this bottom edge here, and then we're going to... No, I'm not. I've jumped ahead. I'm going to delete that combine, and I'm going to do the ruled surface before the combine. Click that edge there, flip this around. It doesn't have to be that far up. It's got to be. We're going to use this surface to trim away this excess here. So this height just needs to be higher than that face there. So we'll just go to about there. Okay, we're going to go into a split. We're going to go to trim solid. The split tool is going to be that. The solid is going to be that one there, and then make sure the arrow's pointing outwards. You can flip it with this, and then okay, and that should trim that back. Right, that's fine. That's fine. Right, we're done with the ruled surface. We can turn that off. Now we can combine that and that into one solid. There we go. Don't worry about this sort of patchwork quilt effect. That's just Inventor's. That's just Inventor's way of showing you that there's some kind of there's no continuity. That's the word I'm looking for, between the surfaces, but that's fine. If you change the view type to analysis, it's not bad. It's not great, but it's fine. You know, if you were 3D printing this, for example, it would be fine. Okay, and then also if you turn it on to realistic, you don't see them either. Okay. All right, back to shaded with edges, and should we put some fillets on this now? I think we probably can. I think we're about right to put some fillets on. We'll go for a, it's got to be smaller than that. We're going to have to go for 0.2, and we can pick up that edge, and then that edge. This might start failing. I'm sort of thinking, oh God, it's failed. It's failed. Please come back. Please come back. Oh, come on, come back. Come back. Come on. Please, 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 pretty please. Don't fail. Don't fail on me. Give me some fillets, mate. Thank God for that. Thank God for that. Right, if it just doesn't work, you can drop the size of the fillet down by 0.2 to 0.1 perhaps, because it is quite large. And that's fine. Yeah, that'll do. That'll do. I'm not going to put a fillet around this edge here. I don't know why, I just don't want to. I'm going to change the type to a smooth G2 fillet as well. If that doesn't work for you, you can just leave it on a tangent fillet, but I'm going to change it to a G2. And that's looking alright, isn't it? Yeah, I'm happy with that. I am happy with that. Okay, and then, what's the next step, Neil? I'm just asking myself questions here, I'm thinking out loud. Shall we? Right, we're going to go sketch on the top here, and then we'll do a center point circle of, say, 3 mil in diameter. Finish that sketch, and then extrude that as a cut to that face there. And then another sketch. No, I'm not going to do this bit next. No, escape on that. Right, circular pattern. We're going to pattern the entire solid, and then the axis is going to be the z-axis, and we're going to create 19 of them. And then okay, and we're almost done. That's almost it. The couple of things left to do is just like textural things and a couple of extra fillets. But apart from that, this might take a while depending on how fast your CPU is, because it's very computationally expensive, this bit. got a lot of fillets and a lot of surfaces to pattern, but it'll be done in a matter of moments. But once this is done, depending on if you're actually physically making this or not, you might want to model an extra keyway in the top here as for a shaft. I don't know. That looks awesome, doesn't it? So like say for example, you could sketch on this top face here, and then let's see, how would we do this? We'd project that edge there, and you could just draw a center point rectangle there to somewhere like that. Can we dimension there? No, that won't work. We'll just go for something like that, and then dimension that to be 2.5. 2.5, finish that sketch, and then you can extrude this as a cut down by 1 millimeter or so. Maybe that's too far because that's going to go into the blade. 0.5. Yeah, the reason I didn't do that beforehand was when we did the pattern, it would have patterned this cut, which would have given us an undesirable result. That doesn't look great, does it? I'm just looking at it, it's going, oh, there's just something not quite right about that. I want to change this down to even maybe further, 1.5. That's better. That's better. All right then, a couple more fillets. 0.1 is fine on the bottom edge here. We should probably fillet these edges here as well. Can maybe window select them like that. That's fine. It's missed that one. We'll do that one. All good, mate. All good. Okay on that. And you've got yourself a turbo impeller. Wait, actually, draw one from the bottom there. Okay. That is looking absolutely baller. This form has turned the visibility of that off. And mate, we're done. We are done. Material, right? I'm using the Autodesk Material Library. You might be using the Inventor Material Library. You can click one or the other. But we can change this to be whatever it's actually made out of. Stainless steel, ABS plastic, whatever it is. Change the texture. I'm using again Autodesk Appearance Library. Change this over to a stainless. Okay, it's up here, isn't it? Stainless polished. That'll do. Hell yes. That looks good. Right, click the top face of the cube, and then we're going to set that current view as front. I might have jumped off the edge of the screen, but just, yeah, set current view as front. View, change this to realistic, turn on all the shadows. We're just doing this for effect now, really. We're kind of done. Turn on reflections, turn on perspective mode, mate, and you've got yourself a turbo impeller. Even better, mate, if you've got a 3D mouse, you can just sort of turn it like this, and then it looks like it's spinning. And for no other reason other than it looks amazing. I don't know what I'm doing that for. But yeah, there you go. There's your turbo impeller. Right, you can save that off. You can export it as an STL and go and print it, or put it in a drawing, DXF it up, or whatever you need to do with it, mate. Whatever you need to do with it. But there you go. There you go as your turbo impeller. And that's it. Yeah, so hopefully that was followable. If not, I don't know what to tell you. It's a difficult one to do when you're doing draggable freeforms. If you do make any mistakes or you want to change the blades, you can go back to the original form and then grab the points and then pull them around. Change that space back to local. Oh, it's pointing down now, isn't it? Don't like that. Let's grab that edge there. It's still down. On there. You know, maybe drag it along a bit further. Okay. If you make any changes to the form at this point, because it's patterned 19 times, it's going to take longer for it to update the thickness and then update all the patterns. So it does become a little bit more time consuming once you've done the pattern. But it should work. It should work. If it doesn't work, you've probably just dragged it a bit too far and it can't compute a fillet. Perhaps that might be the case. Once you do apply those fillets to the edges, you are risking any changes to the body of the fan not actually computing correctly, because the fillets might not solve around all the edges. But I'm confident this is going to work and be fine. Yes, look at that. Look at that. Right, how effective this is as an actual as a turbo, I'm not convinced. There's very minimal airflow going on around here, but you get the idea. You get the idea. All right, mate, that's it. Thank you very much. And thanks to Kevin, who suggested this idea in the TFI Discord server. If you want to be involved in that, get chatting with us and talk about ideas and stuff, and you have to sign up to Patreon, chuck in anything you want. It can be just $1, and it'll get you access into the Discord server. But thanks to everyone who has so far. Thank you for watching this, and I'll see you in the next one. Toodles!